Okay, bit of a video on 7b, polynomial long division. Hopefully you've done this last year, but otherwise have a watch of this video, have a good read of the textbook, you'll be fine. First, let's have a look at long division, just good old normal long division. We've got 274, which is the dividend. Okay, that's what we're going to divide. We've got 13 is what we're going to divide by. It's called the divisor. We've got, at the end of it, we'll get our answer up the top, which is known as the quotient. And at the bottom, we'll have a remainder. First step is 13 fitting into 2. Can't do it at all, so we'll go 13 fitting into 27. Also thinking about this as 27 divided by 13, okay? The answer is 2. Fits in 2 times. There is going to be, it doesn't fit in perfectly though. 2 times 13 is 26. And so when we do 27, take 26, we've got 1 left over. Now, in case you're interested, what this is actually saying is that 13 times 20 is equal to 260. So if you think of, we're trying to divide 274 by 13, we know that 260 divided by 13 is exactly 20. And so we end up with 14 left over, 274 take 260. But the whole point of long division is sort of taking that complication out of things so that primary school students can work with big numbers by just following a process. So we see how many times 13 fits into 27. We write that answer up the top. Then we multiply. 2 times 13 is 26. Then we take away. 27 take 26 is 1. And then we bring down the next column. And then we see how many times 13 fits into that. 13 times fits into 14 once. Okay, so 1 times 13 is 13. 14 take 13 is 1. We can't fit in any more times at all. So we have a remainder of 1. So 274 divided by 13 equals 21 and 1 remainder. And if you do 274 divided by 13 in a calculator, you'll find that it equals 21.08. So we've got that. It doesn't fit in perfectly. Okay, so key point, if there is no remainder, then 13 would be a factor of this. So 13 is a factor of 273 because it fits in perfectly 21 times. So just remembering that for later, no remainder means it's a factor. Let's have a look at long division with polynomials. So we've got, and I wish I could cover things over, but I don't have the energy, so you're just going to have to put up with my lame video. Alright, the equation is x squared plus 7x plus 11. We're dividing by x take 2. We'll pretend we don't know this answer up the top yet. Ooh, it's a mystery. When we're dividing by a linear factor like this, we just focus on the first term, okay? When we multiply out, that's what takes into account the take 2. It would be too complicated if we focused on it as a whole thing. So we're saying how many times does x fit into x squared? Or what is x squared divided by x? And that's a good way of thinking about it if you're getting a little bit confused. So just writing out a little fraction over here, x squared, take x, divided by x. It will cancel down to just a plain x, okay? So we put that up the top. The other way of thinking about it is what multiplied by x would turn it into x squared. Now we multiply x, but we multiply both things here. So x times x is x squared. X times negative 2 is negative 2x. It should always cancel out the x squared after the first line. Sorry, I have a cat attacking my hand. Okay, so now we do the takeaway. X squared take x squared should cancel out. We want to cancel out the power each time. 7x take away negative 2x is 7x plus 2x. So that's why we get a 9x. And then we bring down the 11. Or you can think of it as 11 take 0 is 11. Okay, now we're looking at how many times does x fit into 9x. Okay, it fits in 9 times, nice and easy. 9 times x take 2 gives us 9x take 18. Again, we're taking away here, so that 9x takes 9x will cancel out. 11 take away take away 18, or 11 take away negative 18, ends up adding, so we get 29. So our answer is x plus 9 with a remainder of 29. So x take 2 is not a factor. It's interesting to see it written like this. These two multiplied together plus 29 would equal that. So it's nearly been factorized like a quadratic like we want, but not, because we've ended up with a remainder. So if there was a zero remainder, we'd know that these two are factors of it, and then that would be finding the solutions of that quadratic. Okay, now I've just written up a quick thing of things I want to talk about. Remainder no. Oop. Okay, I want to show you equating coefficients. Where is that example? Here it is. Okay, so this is another way to divide. So this equating coefficients is an alternative to long division, and in actual fact none of the questions request that you do it this way. But you could have a go at it, and it is interesting. It's nice and pretty. It's similar to what you did in question 7 of 7a, with the whole idea that if two things are equal, you can find the missing parts of it by expanding. So basically we've got x cubed take 7x squared plus 5x take 4, and we are dividing by x take 3. So what we know is that because this is a cubic and we're dividing by a linear, that we'll end up with a quadratic left over. And we know there'll be no a value because x times x squared is x cubed. So there's no number at the front there, so we can just straight away get rid of that. There may be a remainder though, and that's sort of different to the first chapter because we don't know that x take 3 is a factor. So something they don't do, and something I definitely like to do, and I don't know why you do without it, is to expand this right hand side. So here it is, and sorry you can't see both at the same time, but I'm doing x times by everything here, and negative 3 times by everything here. The remainder, the r, isn't getting multiplied by anything. It's not part of this multiplication process. It's an adding addition on the end. And so I multiply by x by everything, and then I multiplied negative 3 by everything, and I got the r on the end. And then I grouped together the things that were in front of the x squared, the things that are in front of the x, and then these things at the end, which are like my constants. There's no x's on those. And I just put a bracket. You don't really need a bracket around them, but I just sort of put a bracket around them to make them like a little group so they don't feel lonely. Okay, so now what we do is we can work out what the b's and c equal. So for the x squareds, we know that on this side it was a negative 7, and on our new side we've got a b take a 3. So we make those equal, and b equals negative 4. Hurrah! Okay, so you repeat that. When you end up with the constants at the end, we end up with negative 3c plus r equals negative 4. But now we know what c is from working that out in the previous steps, so we can sort of fill in c and we work it out. And so we end up working out what b and c and r are, and that would be the same answer as if we did long division, and this was the quotient up the top, and this was the remainder. So that is an alternative to long division, and I quite like it. I think it's quite nice. Your questions in the test will probably specifically say which way to do, but I could recommend that maybe knowing this way is a good way to check your answers, and it's a nice way of thinking about it as well. Okay, now quick rundown. Question 1, example 5, explain. So it's just the basic one there. Interesting to notice that there is a 0 remainder, which means that x plus 2 is a factor of this cubic. Okay, so if we know that x plus 2, if that was in brackets, and this was the quadratic part, if we could solve that quadratic part as well, if we could factorize that, we would have factorized this cubic. And that is what we're sort of getting towards. Question 2, it's pretty similar, but there is no, in some of them there's, for example, no x squared in the cubic. So if we're looking at the equation, all you have to do is put a plus 0x squared in there so that the process still works and you're still taking in the x squareds into consideration. And for each question you can see the example that's relevant. So for question 5 we actually have some fraction ones, and example 7 is the best example for that one. It does look complicated at first, but basically you're looking at how does 2x fit into 3x cubed. Okay, and if you write that out as a separate fraction, 3x cubed divided by 2x, you'll notice that you get the fraction 3 on 2, and that the x's will cancel down to an x squared, and so that is how they get 3 on 2 x squared as their answer. This multiplied by this equals this. So yeah, have a go at those fraction ones. Don't stress too much if you find them too difficult, but you should be okay with them. And question 7, again, you're dividing by, instead of a linear, it's a quadratic, but again, it's the same process. And if there isn't an x squared in there or something missing, just replace that in there as a 0 so that it still works for the process. But yeah, as long as you're getting the main ideas of polynomial long division, like in question 1, and you've had a bit of extra practice of different situations, that will be awesome. Cool. Thanks for listening. Bye-bye.